Okay, I'm ready whenever you are.
We'll give these guys a second to sit down.
Okay.
I think they're lining up. You must have gone second. Some of you may want to
All right.
Well, welcome all to the second in this series of 5 lectures on World War I. Our first lecture last week was on the history of it, the causes of it. And tonight, Dr. Gary DeBoer from our chemistry department here at Laterno will talk on the science and technology of World War I. Thank all of you for coming out, and thank all your teachers for doing what they did to you to bring you out. We're glad that you've come. Dr. DeBoer is going to explain to you the connection of Jimi Hendrix to World War I. We were wondering about that. 2 weeks from tonight will be the third in the series, and I'll present on the poets as soldiers in World War I. So we'll take a break next week, and then 2 weeks from tonight we'll come back again. And we hope that you come and bring your friends with you. Dr. DeBoer.
Okay. Well, the connection with Jimi Hendrix will come clear later on here in a little bit. Okay. So, good evening. I must say that I'm quite anxious tonight. Following Dr. Kubrick, the famous historian, and this sort of talk is a little intimidating. But despite my anxiety, I'm still thrilled to be here and to talk about chemistry of World War I. Dr. Kubrick is a historian. Dr. Watson is a literarian. We will hear from Dr. Tallum, who is a theologian. So I guess that makes me a chemistian. Okay. So of all these brothers, I am the least, as I am just a chemistian who God has blessed. And though I'm the least of these, my brothers, I have the best topic. I get to talk and likely learn from you about the science and technology of World War I. We will talk tonight about technical advances in the air, in the land, under the sea, and then we will discuss the topic of chemical warfare. Yes, we will keep the best part, chemistry, until last. Because of the nature of this talk, I will be doing something that I don't usually do, and that is, I'm going to be reading from my prepared notes, okay, which I will make available on my website, and I have some hard copies here available for you as well if you'd like to pick them up on the way out. Okay. Before we get started on science and technology, let me try to provide a brief overview of World War I. Wars and rumors of wars. This appears to be the inevitable end of humanity since we ate of the tree of knowledge. With respect to World War I, what specific events or circumstances led to the beginning and the end of this specific war? Can we learn anything from this war, or are we doomed to repeat the mistakes to the end of time? It is said that World War I began in July 28 of 1914 and lasted until November 11, 1918. It began with the assassination of Archduke Franz Ferdinand of Austria and his wife. A lot of people don't know that. His wife was assassinated as well. Okay? On June 28, 1914, by a Serb named Gavrilo Princip and his accomplices. Apparently, there were some territorial disputes between Austria and Serbia. Within a month, the world took sides. Okay. The UK, France, and Russia formed what was called the Triple Entente. Okay. And the German Empire, the Austria-Hungarian Empire, if that's how you say that, okay, formed what we call the Central Powers. Okay. Later, the Ottoman Empire would join with the Central Powers, and so you have all three of these, as well as Bulgaria. Okay. Now, the Triple Entente is also known as the Allies, and since that's easier to pronounce, that's what I'm going to say from now on. Okay. All right. Now, the war drew to an end on what we call the Eastern Front here between Germany and Russia around 1917, because you may recall there was a little trouble in Russia at that time called the Russian Revolution, and people were calling for peace, land, and bread. Okay, and that eventually led to the Russian Revolution and the Soviet Union as we knew it back then. Okay, on the Western Front, over here, things got bogged down for quite a while, but eventually they came to an end in 1918 when the Germans tried to push into France but were pushed back by the Allies, and then things sort of came to an end. And that was November 11 of 1918. In 1919, there's the famous Treaty of Versailles, signed in Paris, which officially ended World War I. Woodrow Wilson then set up the League of Nations, and that was developed so that World War I would never happen again. Okay. World War I changed the face of Europe. On the left you see before, on the right you see after, and you can see that these great empires of Germany, Austria-Hungary, the Ottoman Empire are no more. The Russian Empire was no more. And so World War I had drastic impacts on the face of the map of Europe. Okay. Right. So, World War I was much more deadly than some of the wars that were previous to it. Okay. Why is this? If you look at this, World War I killed maybe 20 million people, while the U.S. Civil War killed 600-some thousand. The French Wars of Napoleon, maybe 2 million. Why this order of magnitude increase in the fatalities in World War I? Well, much of it has to do with the technology that they had in World War I they didn't have before. Okay? So let's begin by looking at aircraft, or things in the air during World War I. There were balloons. This is old technology, things that were used way back into the 1800s. Okay, so nothing new here, but these balloons were used for all kinds of things, for observation, for reconnaissance, to drop chemicals later on, and we'll talk about that in a little bit. But there was also some new technology in the air, and you may recall that in 1903, these brothers flew a plane at Kitty Hawk. And that was in December 17 of 1903, just 10 years before World War I. So 10 years later, where did my clicker go? There it is. We have the modern World War I aircraft. Take a look at this. So we go from Kitty Hawk, the little 1-minute flight, to these airplanes with machine guns, and later on you'll see bombs on them, okay, carrying multiple passengers. Okay. So the aircraft advanced quickly over the next decade since Kitty Hawk. Many of these planes had synchronized machine guns, which is a big invention that allowed the machine guns to shoot through the propellers without hitting the propellers, which would have been a bad thing to have happened. Okay? All right. Okay, and if I can drag this off a little bit, I can show you some bombers. The bombers, nope, that's aircraft. Where's the bombers? No, that's not the bombers. Let's get to the bombers. Aha. Duels in the sky. No, we're going to go a little bit further to bombers. Here we go. This is really neat. Okay. So this is Germans first developing bombers using aircraft. And watch these guys put the bombs on here. This is actual footage from World War I. Okay. Here you go, buddy. Snap them in. Okay. Good job, Hans. And now look at this one. That must be a 100-pounder. Okay. Could possibly contain chlorine, which we'll talk about later, or phosgene. Here they are, stacking them inside. I guess they're just going to drop those out or something. Okay. And it's a push plane. Okay, which is kind of neat if you're in aviation. Okay, how many aviators here? Okay, a few of you. All right. So anyway, big improvement over balloons. Okay. Okay. Let's go back to our talk, unfortunately. Here we go. So the most famous aviator of all time probably came out of World War I. Okay. And that was our friend the Red Baron. Okay. Also known as Manfred von Richthofen. Okay. And the Red Baron shot down 80 planes between 1916 and 1918. And unfortunately, he himself was shot down and died on April 21, 1918. Or fortunately for the Allies, perhaps. Now, there are also Allies planes. Here's the Red Baron again, the triplane. Okay. Again, a big step in just 10 years from that little thing that was at Kitty Hawk. So here's one of the Allies planes, the Sopwith Camel. They also had the Sopwith Snipe. Okay. So here we have aircraft. Okay. Okay. Now, everything in the air was fluid, things flying around all over the place. Not so fluid on land, however. Okay. The war quickly bogged down into trench warfare on the Western Front here between Germany and France. And these guys dug in with trenches and secondary trenches and all kinds of trenches. Okay. Why? Why was this so entrenched on the Western Front? Well, much of it has to do with the defensive weapons that were developed for World War I. And one of those was the grenade, the hand grenade. Okay? And these grenades, they were packed with not just explosives, but also with gas canisters. And we'll talk more about the gases that were involved in these things a little bit later. Another thing that we have in World War I that we didn't have before that sort of entrenched things on the Western Front was Big Bertha. Okay, the Germans had this big howitzer, which sent big shells down from steep trajectories, and they fell on the soldiers, and things are pretty well entrenched. It's from this that we get the term shell shock. Came out of World War I. Okay. Flamethrowers, or Flammenwerfen, depending on who you were using them, was also a scary thing for soldiers in World War I. Think about that if you were stuck in a trench and somebody snuck up on you with a flamethrower. It would be bad news for everyone. We've already mentioned machine guns used on aircraft. Machine guns were also used in the trenches. Okay. Most of the European machine guns were based on this Maxim design of 1904. Over on the left, you see the Gatling gun. That was used in the Civil War in the U.S. There the barrels went around. In the Maxim, you can see that there's a belt of bullets there that slides through the gun, and there you go. Here's another one. Okay, you can see a little bit better. These things ran really hot, so they were water-cooled on their barrel as well as air-cooled. Okay, and they were called the Queen of the Battle because they were everywhere, and they sort of ruled the trench warfare. People blasting each other, 400, 500, 600 rounds per minute. Okay. So there's another one shooting at each other. Now, if you're German, it's not a machine gun, but it's a Maschinengewehr. Yes? But basically, it was the same design, the Maxim, or later it was called the Vickers machine gun. And it took several operators. These things were over 100 pounds. You needed a few people and maybe a horse to haul it around. You needed somebody to run the ammo through so it wouldn't get chunked up, and somebody else to shoot it. Now, the Americans were a little bit more ingenuitive. I guess they went to Laterno or something. And they came up with the Browning. The Browning is very different than the European Vickers. It was much lighter, maybe 50 pounds or so. And so that helped a lot. And so they had the Browning M1917. Now look here. This machine gun and iterations was used not just in World War I. It was also used in World War II, Korea, and Vietnam. Yes, this was like at the beginning of a whole era of machine guns here in World War I. Okay. Now, 50 pounds is pretty heavy to lug around even. Okay. But it's not as heavy as the next thing that came out in World War I, and that's tanks. Yeah, tanks. We didn't have tanks before World War I. Tanks were an answer to the trench warfare. In 1915, the British developed this, the Little Willie. Okay, it was based on the design of an agricultural tractor. The Mark I soon followed, okay, in 1916, and was 26 feet long, and was initially called a land ship. Okay. Now, instead of being called a land ship, it became called a tank for a couple of reasons. It was said that the manufacturers who were working on it had to tell people they were working on a mobile tank rather than a weapon. And they also thought it looked like a tank. The Mark I traveled at about 4 miles per hour, and it took several people to control. Notice how well established they are in the trenches here. It was not a very reliable thing, and it could travel only a few miles before it would overheat. Yet it broke through the lines at the Battle of Fleur, if I pronounced that correctly. And that's a big thing when you're entrenched. The Mark II, 3, 4, and 5 would soon follow. Notice the wheel on the back? That's how it was steered, like a ship with a rudder. And the infantry would follow the tanks across the trenches and see if they could hold their ground. That's the funny part. Okay. All right. Now, the French, they also had a tank. Okay. And this was built by Renault, a little sports car company. Okay. Called the FT-17 for 1917, apparently. And it was much smaller than the British model and was called the Mosquito. Okay, let's take a look at the Mosquito. Oh, sorry. There's an ad.
Much more advanced.
Yes, it was. All right. Now the Mosquito looks much more like your modern tank. It's got a rotating turret on top, and the tracks are lower on the tank. Okay, so here it goes. The British and the French manufactured thousands of tanks on the Western Front, while the Germans were able to produce only 20. Yeah, Germans were sort of were behind in the tank race there. I don't know about you, but this all looks pretty chaotic to me, doesn't it? Yeah.
So many people walking so close to those tank treads.
Yeah.
I know I wouldn't like to be there.
Mm-hmm. Yep.
Can we build one of those?
Maybe you guys could do it with 3D printer, huh? Okay.
Plastic tank.
All right. Okay. Well, let's move on here. All right, so we've covered the air, the land, and now the Germans get the advantage under the sea. Okay? The Germans had the Unterseeboot, or the U-boat as it was called, and this is a major investment in the German strategy to defeat the Allies. These are battery-powered submarines. Diesel generators were used to charge the batteries when the U-boat was not submerged. Okay? And what do you think? I got a video of U-boats. Okay. So here they are out in the shipyard, climbing onto their boat. Now, early in the war, there was no defense against this shark of the sea. Later, there would be some counter-warfare efforts. Here they're loading the torpedoes. And again, kind of chaotic, isn't it? Look at this thing. I don't think OSHA would approve, would they? Okay. All right, let's advance the film here a little bit. Okay. Maybe a little bit more. They're still loading things up here. Let's go out to about 6 minutes here, and we can watch an exciting event. Okay. So here they are out at sea. Okay. And they're diving. Music getting more exciting. So loading the torpedo here. There is the ship calling in. Fire torpedo, Scotty. Boom. And there it goes. Okay. So another one bites the dust. Yes. Okay, so the U-boat was embarking the coast of Britain there. Okay. And even though later on there were some defensive developments, it wasn't soon enough for some ships. Here's your depth charges that were dropped as a defense against U-boats that later developed, but not before the Lusitania. Lusitania, the RMS Lusitania, British ship, with many American passengers on board, was sunk by 2 torpedoes from a German submarine on May 7, 1915. Though the Germans would apologize to the U.S. for this loss of American life, the sinking of the Lusitania and other ships would eventually be one of the rallying cries for U.S. declaration of war on April 2 of 1917. Here is a famous oil painting of the sinking of the Lusitania from a German museum. Here is some newspaper clippings. Okay. 1,260 dead. Can you imagine a country not doing something after something like that? Okay. A little later, U.S. is at war. Okay. More ships are sunk. Okay. What did Wilson say? He said, "It is a war against all nations. American ships have been sunk. American lives taken in ways which have stirred us very deeply to learn of. But the ships and people of other neutral and friendly nations have been sunk and overwhelmed in the waters in the same way." When I addressed the Congress on the 26th of February last, then he was trying to stay out of the war, I thought that it would be suffice to assert our neutral rights with arms, our right to use the seas against unlawful interference, our right to keep our people safe against unlawful violence. But armed neutrality, it now appears, is impracticable, because submarines are in effect outlaws when used as the German submarines have been used against merchant ships. It's impossible to defend ships against their attacks. And so America went over there to go to war. Your mosquito tank? All right, so what did the Yanks find over there? Well, they found chemical weapons. Weapons of mass destruction, you might say. Tear gas. Tear gas was used in World War I. Gas is a bit of a misnomer here, as most of these agents are actually liquids at room temperature, though it is the gas vapors of the liquid that are effective. In August of 1914, 1 month into the war, it is reported the French used ethyl bromoacetate. All the general chemistry students could name that. Okay. They used it in grenades. Didn't work very well. Later, these and other chemicals were delivered by artillery shells. The Germans used tons of xylyl bromide, okay, against the Russians at the Battle of Bolimo, if that's how we say that, in January of 1915. Fortunately for the Russians, the weather was cold, and so this greatly diminished the amount of xylyl bromide vapors that could get into the air. And so these same agents are used today by police and riot control. And so take a lesson. If you are planning a spontaneous riot, schedule it for a cold day so the tear gas will not vaporize. All right. Now, why do these chemicals cause you to tear up? Okay. Cough and otherwise get sick. Well, you notice that both of these chemicals contain a bromine atom on them. Okay. General chemistry and organic chemistry students would call these alkyl halides. Okay. And most of the lacrimators are tearing agents, that's what we say in chemistry. And most of them are alkyl halides, either chlorine or bromine. Okay. And it's the property of the alkyl halide that's responsible for this chemistry that initiates the tear response. And what is this chemistry? Well, chemistry is not obvious, and it's still not that well understood, but it likely involves the electron-poor carbon. This carbon is going to be electron-poor because next to him he's got a greedy bromide and a greedy oxygen. Okay? And that carbon is going to be poor, and because he's poor, he's going to interact with electron-rich nitrogen atoms that are found in proteins and other parts of your body. Okay? Linings of your eyes, and your throat, and your nose. And that's what's thought to be the chemistry here with these things. Okay? Now, why these chemicals? Well, these chemicals had already been produced in the chemical industry for the production of other chemicals. They were known chemicals, not specifically developed as warfare agents, but they worked. So, again, everything had to be right. Though tear gas exposure can lead to pneumonia, in general, it's not deadly. Okay? However, the next contestant on chemical warfare tonight is chlorine. Okay. Dr. Hathaway is happy to know that's not an organic agent. Yes. All right. Chlorine, CO2, unlike the liquid tear gas agents, is, with a boiling point of minus 34 degrees C, a gas at room temperature. Chlorine, unlike tear gas, is deadly. However, to be deadly, the exposure needs to be high, which in the outdoor war theater can be a difficult situation to achieve. Low concentrations of chlorine can cause blindness and respiratory damage. This famous painting, called Gassed by John Singer, shows a group of soldiers blinded by chlorine attack, being led to safety. What is the chemistry involved in these chlorine attacks? This chemistry is a bit more clear than that of the tear gas. It's well known that chlorine gas dissolves in water to form hydrochloric acid and oxygen gas. We also know that both chlorine and hydrochloric acid can add across carbon-carbon double bonds, right, general chemistry students? Okay, to form what? Alkyl halides, also known as lacrimators or tear gas. Okay. We also know that chlorine can dissociate into a radical, a free radical, and like your radical professors, they can do you great harm. Okay. Chlorine gas attacks were first used by the Germans against the French in the Second Battle of Ypres in April 1915. It's reported that the French thought that this yellow-green cloud of gas was a smokescreen to hide the movements of the Germans. So they rushed straight into the cloud, only to be panicked and dispersed. Until then, gas attacks had been non-lethal. With chlorine, there was no holding back. This was a fight to the death. Both the British and the Germans were to use chlorine again. The trouble is that the gas goes where the wind blows. It is toxic to both your enemy and yourself. To get it to the enemy, gas artillery shells were developed. If you do get it to the enemy, it may kill slowly and painfully. Death by chlorine gas is very different than death by the queen of the battle, the machine gun. With the use of chlorine gas, deadly gases are now on the table. What else can we use? How about phosgene? Dichloromethanol. Again, general chemistry students could name this. Okay. Phosgene. Easily produced from carbon monoxide and what? Chlorine. Yes. But it is slower in doing the killing. It's more deadly than is chlorine, but slower. Which is an inconvenience in war if you still have to fight people for a while they're still dying. So phosgene was also... Yeah. Time to take a drink. Okay. So phosgene was often combined with chlorine gas for faster action and best overall kill rate. The phosgene-chlorine mixture was called the White Star. 88 tons were first used by the Germans and the British in December of 1915. Now of this, there was only 69 deaths and 1,000-some casualties are reported. Phosgene and chlorine gas were the most manufactured warfare gas of World War I. 90,000 tons of chlorine, 37,000 tons of phosgene, and a total of 190,000 tons of all chemical warfare agents. Now, why is phosgene deadly? Well, the molecule is small, okay, and you'll notice that the carbon here is very electron poor due to greedy chlorines, 2 of them, and a greedy oxygen, making that carbon very electron poor. And therefore, when you have a rich nitrogen atom in protein or other tissue of your body, it's soon going to react with it. And because it's so small, and if you breathe it in as a gas, it's going to go way down into your lungs, and it's going to destroy that respiratory membrane, and that's what's going to kill you. By the way, in Greek, phos is light, and gene is birth. So phosgene means the birth of light. Okay, so if phosgene isn't enough for you, you can put it into 100-pound artillery shells and shoot them with your big Bertha and try to get people across the trenches there that way. Don't like phosgene, you can try mustard gas. What is mustard gas? It's what we call a cytotoxin and a vesicant, which means it is toxic to cells and it's a blistering agent. The Germans coated their mustard gas shells as yellow and the phosgene chlorine shells as green. Mustard gas came to be called the Yellow Cross. It's first reported used by the Germans again in not the second but the third Battle of Ypres. That must have been quite a place. On July of 1917. It's a liquid at room temperature, like tear gas, because you can see it has the alkyl halide functionality over there. Okay? But it can also react with itself. As you can see here, to make what we call a sulfonium ion in aqueous solutions, which is what your body usually has. Okay? Unless you're dehydrated, which doesn't matter because you're dead anyhow. Okay? And it's these positively charged sulfonium ions here that are going to cause all the trouble in your biochemistry. And they're going to attack, again, electron-rich places like double bonds, nitrogen atoms, okay? And that's what's going to cause all kinds of trouble. Okay. So, we have discussed some of the chemical warfare weapons of World War I, tear gas, chlorine, phosgene, mustard gas. All of these, at the time, were illegal to use in war. The 1899 Hague Declaration, okay, and the 1907 Hague Convention all outlawed the use of chemical warfare agents in war. So use of these was all war crimes, technically. Let's have a little review of these things. Where's my clicker? Ah, there it is. Here we go. So here's a short little video review of what we talked about with respect to chemical warfare agents.
World War I was known for its many military innovations. From the Royal Navy's first use of tanks or land ships to the first combat aircraft designed by Germany, many of these inventions would go on to completely change how wars would be fought. Among these, some of the deadliest and most debilitating weapons were the chemical weapons of World War I. The first use of chemical weapons came in the form of tear gas. Originally used by the French and then the Germans, it proved incredibly unsuccessful as it would fail to work in freezing climates. It only had the effect of disorienting the enemy, which proved not to work effective in combat. As the war progressed, the Germans proceeded with the use of chlorine gas in the Second Battle of Ypres, where a huge cloud of chlorine was released against the British, Canadians, and French. The effects were devastating. It caused severe choking and destroyed the internal organs of the victims. The Allied forces had to evacuate the area, and the Germans were afraid they too would succumb to the chlorine if they advanced into the newly captured trenches. Worldwide condemnation followed Germany's use of chlorine gas. However, since Germany was already utilizing chemical weapons, it left no choice but for the Allies to use chemical weapons as well. The British attempted to retaliate with chemical weapons, but failed miserably. At the Battle of Loos, the wind would blow back the chlorine into the British side, resulting in more British casualties than German. This setback resulted in a shift to put poison gas into artillery shells, and allowed for more varieties of weapons such as phosgene and mustard gas. Among the new chemicals used were others such as paralytic nerve agents and bromine. However, the most used were mustard gas and chlorine. If the war were to last until 1919, about 30 to 50% of all artillery shells would have had some form of chemical weapon. By the end of the war, about 130,000 tons of gas had been used. However, many problems remained with these weapons. Mustard gas would get trapped in the soil and remain poisonous, making capturing trenches very dangerous. The Great War showed that, on an overall scale, chemical weapons proved to be largely ineffective in battle. Once thought to be the weapon which would turn the tide of war, all sides began using it with great consequences. Countries such as Britain, France, and Germany experienced hundreds of thousands of casualties and several thousand deaths. By the end of the war, about 1.2 million soldiers would come back with the debilitating effects of these chemical weapons, but no country showed any real gain from using them. In 1925, all countries agreed that since the costs were too high and the advantages too little, they would all sign an agreement to ban the use of chemical warfare.
Okay. So, we've discussed here what might be called brute force chemical warfare agents. Okay? These agents were off-the-shelf chemicals at the time. Since then, other chemical warfare agents and biochemical warfare agents have been specifically developed. Sarin nerve gas, for example. Yet despite these new arrivals, the old chemical warfare agents of World War I are still used today, as you hear about in Syria and places like that, but not by everyone. In 1992 and 1993, a chemical warfare weapons agreement was developed and was signed by most of the world's major powers, including the United States. The convention went into full effect in 1997. Since the signing, the U.S. has destroyed all of its chemical warfare agents. Most of this destruction took place on a tiny atoll, now decommissioned, and it's a bird sanctuary, out in the middle of the Pacific Ocean, called Johnston Atoll. See Johnston Atoll? Right up there. So south of Hawaii. Okay. See Christmas Island there. Yes. The Marshalls, where the U.S. tested their nuclear bombs. Okay. Okay. So, anyway, some 20 years ago, before it was used to incinerate chemical warfare agents, I was on Johnston Atoll. I was in transit traveling to the Pacific, and the plane stopped at Johnston, which was then a U.S. Air Force base. Military personnel came on the plane to escort some people off and others on, and we were instructed to have our shades drawn at all times. An interesting place to visit, but I wouldn't want to live there. World War I is also an interesting time to visit in history, but I feel fortunate that I did not have to live through it. Go. Unfortunately, my grandfather, William Keeper, my father's father, was not so lucky. He was drafted into World War I in May of 1918. However, fortunately or not, for him, there was a flu epidemic in 1918. It was called the Spanish flu because it was reported to have been worse in Spain, though this may be due to the fact that Spain was neutral in World War I and the war countries didn't want to report so many casualties due to the flu. Okay? The Spanish flu of 1918 was the first of the H1N1 virus, and is thought to have killed 50 to 100 million people. Perhaps that puts World War I into a different perspective. Speaking of perspective, the World War I soldiers were issued a small book, a common book of prayers, Episcopalian, I believe, and in it was the prayer of the soldier. We ask soldiers to do their duty, but I think we also, as the people who do the asking, have a duty. I think the Proverbs issue some good advice for all of us. Perhaps Watson and Talum will also give us some advice in the weeks to come. With that, I am open to your questions and comments. Thank you. Questions from the audience? Anybody? Everybody ready to go home? Oh, okay. Yes.
You mentioned that this war, the use of chemical weapons kind of demonstrated to everybody that it wasn't worth it. Do you think that will hold true in the future? Do you think there could be a reoccurrence or a resurgence of the use of chemical weapons?
Oh, good. You know, the use in World War I was not very effective. Yes? But as you could see, there were efforts to put more of these gases into artillery shells, which would make them more effective. And since then, we have much more effective chemical warfare agents than we had in World War I. So I would assume that those who are desperate will see some advantage in using these and will do so, as we've seen in some places already, in Syria, for example, and other places. So I don't think they're going to go away. Chemicals have been with us and will be with us, and people will use them, I guess.
They're serious enough that within the last year, when our country was considering military action in Syria, that was sort of the locus of
the red line there.
The red line, exactly.
Yeah. Other questions? I must have done a really good job. Yeah, yes.
What role did the development of the radio play in World War I?
I don't know. That's a good question. Okay, I'll have to look into that. I didn't see anything particularly when I came around that. Radio's been around for a while, so I don't know if it was new
They
in
had a lot
World
of
War I.
cable or wire for
Yeah.
communication.
Yeah, I'm sure they did. Yeah. Other questions? No chemistry questions? That's what I know about. And I tell you all this other stuff that I didn't know anything about. And you guys don't even ask me about what I know about. Yes? Okay. Yes, chemistry question, Ms. Tuck.
I guess like the chemicals that were used in the war, is there still ways that it could affect people that live in those areas now? Like would the chemicals still be sticking around or?
No, I don't think so. No. No, the tear gas and chlorine, it all evaporates away after a while. Phosgene, too, will evaporate away after a long time. So, no, I don't think so. Now, if you go to Bikini Atoll or something in the Pacific, we go back that way. Now, there you got trouble, because that's where the U.S. tested their nuclear fusion bomb, which was particularly dirty. And Bikini Atoll is still hot. You can go there, but you just can't eat anything or breathe anything or anything else. So that's kind of interesting. So, yeah. All right. Other questions from the audience? Yes.
So these chemicals that you've been talking about, like mustard gas, etc., is there any like something or other that can be used to neutralize them?
Well, that's an interesting story. You know, like I said, most of these things react with the nitrogen-containing atoms in your proteins and stuff, right? So what the World War I soldiers would do quite often is urinate on a cloth, which urine contains a lot of nitrogen in it, and put that urinated cloth over their face so that the mustard gas and chlorine would react with this urine in the cloth and not get into their lungs, their eyes. So yes.
Well, sounds like it worked.
Yeah. Yes.
You had mentioned around the time they quit using the chemical weapons, nerve gas was developed.
No, sarin was developed much later. You know, you can say mustard gas is a nerve gas of some sort, but not a designed sort of nerve gas. So these designed chemical warfare agents came later, you know, in the 60s and things during the Cold War and stuff like that. These are just common chemicals that were made by the ton, that were around, cheap, dump them on people, you know, and that's what we do. Yes. Oh, sorry, let's get Tyler up there since you already had one. Yes, Tyler?
You said these are off-the-shelf chemicals. Where did the mustard gas come from? What process or industry produced them?
Well, all these alkyl halides are used as precursors for other things, making esters, like perfumes, and all kinds of stuff like that. So what you can make perfume from, you can also make into chemical warfare agents. Just take one element off, right? Yeah. So, yes, Rory?
Later on, during the war in Vietnam, where they used napalm and stuff like that, they kind of got the idea from there. And I was wondering how that carried over with the treaty they made about chemical warfare.
Yeah, the Geneva Conventions. Well, you know, Vietnam was before 92 and 93, right? But it was after the Geneva Conventions. Of course, it was Agent Orange, which was worse with respect to biological systems than napalm. Napalm just burned really hot, and so you couldn't survive that. But Agent Orange, defoliage, that was supposed to kill the jungle so that you could see the enemy, also had a lot of bad effects on people. And those, you know, Vietnam veterans have troubles with Agent Orange from, you know, for even now. So yeah, that's a big trouble there from Vietnam eras. You bet. Yep. Any other questions or comments? If you guys would like copies of my prepared notes, I've got some up here. Okay, you can come on up and grab one before they're all gone, because I bet they're going to go like hotcakes.
Before you move,
Yep.
you need to sign in for credit for a class. Dr. DeBoer has a number of sheets here for the chemistry students. Dr. Beck has
You're
one
welcome.
over here on this table. If you need something that's not on the table, there's a tablet over there you can sign
I'm
up
Sandra
on.
Rowell, and I'm with Lafana Foods, and we manufacture corn and flour tortillas. Lafana Foods is good.
I got a question for you. During World War I, my grandfather was in World War I. To the best. He died before I met him. He died in the late 1950s. And how many casualties? Do you have any idea? Or did you find that with mustard gas?
Actually, not that many. You know, mustard gas, really nasty, blinded a lot. So there's probably 1 million of casualties, but not nearly that many deaths.
Okay, because I know he had problems with his lungs until the end of his days.
Yeah, and that was probably due to mustard gas or chlorine.
Thank you.
Thank you. Most of these things weren't deadly, but they certainly ruined a person for the rest of their lives, right? So, so that's nasty. Maybe
But there is one in my family. I know she was chemical. My daughter's taking biology, but she's up at the University of Tennessee.
Do you want one?
I can make I'm originally from Pennsylvania.
Oh, okay. All right. Well, thank you for coming in.
Yeah, I appreciate it. It was interesting.
Okay. All right.
Thank you for your lecture today.
Thank you. Okay. And what's your name?
Dave Johnson.
Dave Johnson?
Jeff Johnson's son.
Oh, okay.
If you know Jeff Johnson.
Who's Jeff Johnson?
He's one of the professors.
Okay, what's he teach?
Teaches.
Oh, he's in engineering there. Okay, yeah, I think I know him.
SolidWorks.
Okay, yep. Okay, well, did you enjoy that talk? Okay, good.
And I also get extra credit for a class at Spring Hill School,
okay.
so I was wondering if I could have your signature or something.
Sure.
Show that.
Sure.
No, I'm just a sophomore.
Okay, I'll sign the back of my card.
World history class.
So, what was your first name again?
Gabe.
Gabe Johnson? Okay. So, Gabe Johnson was at my WW1 chemical warfare talk on 10, was it the 9th, I think? 09/14. Sign my name there. And if your teacher has any questions,
Thank you.
call me.
All right. And
Okay?
your notes are online? He has to write a summary.
No, not
too,
yet.
so-
I'll put them up online.
Okay.
I don't know where all the other copies went. You can have
They
this copy
disappeared,
if you
yeah.
want.
Oh, it's fine.
We
Yeah.
can get them off
Okay.
online, or,
Yeah.
or if
Yeah,
you
or I
forget
can
to, I'll
send them
just
to you.
email
Yep.
or something. That's
Yep,
fine.
yep.
That'll work.
Thank you.
Okay. All right. Thank you.
Appreciate it.
All right.